Hi, I'm Liz Nedden. Let's have a look at Venn diagrams when we have three events. So when we're talking about three circles now, we've got the three individual events, A, B and C, and we've got those areas. So if I was just to look at, for example, A, then if I can colour in a different colour, I'm going to colour in my B. So I can see the green area there where I've got both A and B occurring. But if I now colour in C in a different colour, we'll see that there are combinations. So there's an area that I've shaded in 3 times, which is the all three sets, A and B and C. I've got an area which is just A and B, and then I've got just A, just B. I've also got A and C, B and C, and just B, just C, and what's outside. So our little example down the bottom, if we have a dedicated teacher and students do lots of hard work and they regularly attend class, then in the middle, those intersection of all those three will usually get you some good grades. However, if we just have dedicated teachers but not hard work and no regular attendance, we might only get a C minus. If we've got students who have got a dedicated teacher and work hard but don't regularly attend class, maybe they'll get through to some kind of B, and so on. So we can see, depending on what the issues are, we can get different results. Let's have a look at an example. So this is just now looking at the understanding of what areas relate to our unions and our intersections. So when I talk about B, okay, just B, that means anything, I'm just going to colour in that circle B. Everything inside there is related to event B. If I do A union C, so union means it could be an A or, remember union means or C. So I'm going to, anything that I colour in A will meet the criteria, and anything I colour in B meets the criteria. Oh, sorry, not B. Let me undo that. It should be A or C. Let me rub that bit out. So A or C. So I'm going to colour in anything that's inside C. Now A intersection B, so it's where both A and B occur. So if I colour in one colour in A in one colour, and now I'm just going to switch to a second colour. If I colour in B in blue, then the intersection is the part that has been coloured in twice. So the actual answer to this one, and I'm just going to draw this down below. There's my A, B and C. Then it's this area in the middle there, that is my intersecting part. So if I think about it as a multi-step process, it's the area that I've coloured in twice. Whereas union, I just need to colour in one. Now with a bar above it, the bar means not. So it means everything except for A. So I'm going to take circle A, and I'm going to colour out everything except for that circle. So everything outside of A meets my criteria. Now we're starting to get a bit tricky. Okay, so brackets, like Bedmaster rule, do the brackets first. C union A. So the union of C and A. So the union of C means anything in C or anything in A. So I'm going to colour in anything in A and anything in C. So that's all of that. And I want to know, where does that area intersect? So that's what our intersection is. Now where does this intersect with B? So I'm going to draw that in a different colour. So let me change my highlighter to yellow, and I'm going to highlight in B. Now the area that has been highlighted twice, that is the answer to this. Okay, so if I now draw this, the final answer as a separate diagram. So this has kind of been the working to get to this. The area that's been highlighted twice is my answer. So it's this piece in here and in there and this bit in there. So all of that part, that is my C union A, all intersecting with B. Now what about this next one? So A intersection B intersection C, so it's where all three of them intersect. So it's that very little middle piece there where all three of those things occur. Now not A, so that means everything outside of A. So let me just colour in everything outside of A. So everything outside of A. I want to know, where does that intersect with C? So let me colour in C in a different here. So where does that intersect with C? Oh, come on, behave. So C, colour in C there. So I want to know the area that I've just coloured in twice. That will be the things that meet that criteria. So let me draw the final answer down here below. It's my three circles A, B and C. And it's the things that I've coloured in twice. Let me just there. And it's this piece here. So it's this area down the bottom. This part in here and this part in here. So there's my not A intersecting with C. And the last one in the sequence, so brackets, I want to do that bracket part first, where A union not B. So anything that's in A or not in B. So B, not B, is everything outside of B. So I can colour in everything that's inside A. And now I want to colour in everything that's not in B. So that would be all the stuff on the outside. Plus this part of C, just not the bit that is B itself. So all of that is my union. So that's A union not B. So that is this A union not B. Now I'm going to switch to another colour. And I want to do not C. So not C, I'm going to do it in yellow. So not C, so think about C, and I want not C is everything outside of it. So I'm going to colour in everything that is outside of C. So that will be it's all of this outside there. Could be inside here and inside here as well. So everything that's now been coloured in twice, that is the intersection part. So let's draw in our final solution. So the things that have been coloured in twice, well, that's everything around the outside has been coloured in twice. So that's all of this part here. We've also coloured this part in here in twice, that part twice, and that's it. So there is our final solution. Now let's take these ideas and apply them to an example. So here is our question. We've got a group of students who were asked which of the subjects they take, art, bio and chemistry. So we know we've got 215 students altogether, so I'm just going to put a little note, 215, because that's how many I've got in total. Then I know that there are 3 studying all 3 subjects, so that's right in the middle there. There's 3 right in the middle, so I've dealt with that. 11 students do art and bio, so that's art and bio together. So that tells me that this whole piece here has to equal 11. So if one part of it's 3, then I know that this part here must be 8, because 8 plus 3 adds up to 11. Okay, now let's go. So that's dealt with that one. Next one, 26 students do bio and chemistry. So bio and chemistry. So that's this section here has to be 26. So if I've got 3 in one part of it, this part here must be 23. So done that. I'm just going to switch colour again. Then I've got 5 students doing chemistry and art. So chemistry and art, that is this piece here. So that whole piece there has to be 5. So if I've got 3 in one part of it, then this part of it must be 2. Now I can try and fill the rest in. 50 students study art. So that's circle for art. Let me, different colour here. So this whole art circle has to add up to 50. So 8 plus 3 plus 5, and take 50 away from that gives us 37 in here. Then I know that in the biology circle there have to be 80. So 8 plus 3 plus 23, take that away from 80. That leaves me with 46. And 60 students take chemistry, so the chemistry circle has to be 60. So 2 plus 3 plus 23, take that away from 60, gives me 32. Now I need to know, well, the whole thing has to add up to 215. So I'm going to do 215 minus every single number I've written down. And that leaves me with 64 students who don't fit in any of those circles. So the answer to our question, how many students took none of these subjects? Well, there are 64 students who didn't take any of those subjects. Thanks very much for watching.